Welcome to Tech Voices. My name is Drew Bond, and I'm the president and CEO of C3 Solutions. And we're really delighted to have today with us John O'Donnell. John is the CEO of Rondo Energy. And Rondo Energy is a California-based startup that's on a mission to deliver the world's lowest cost, zero carbon industrial heat. I'm looking forward to learning more about your technology. John, how are you today?
Doing well, thank you. Thanks so much. It's a pleasure to speak with you.
Yeah, thanks for joining us. I'm really interested in learning more about Rondo. One, where did the name Rondo Energy come from? I'm curious.
My wife is a musician. Rondo is a musical form, I think from the 18th century, where the same melody comes back again and again. And a number of us have been working together in previous companies for about 15 years, so we were getting the band back together. And I think other folks have said, well, it's about energy storage and reuse. So you can choose which one, but the true
I,
story is my
I
wife
love
came
that.
up with the name.
I love that story. I love that story. So tell us a little bit more about your background, and then let's get into the company and the tech. How did you get into this business?
Yeah, I was originally a computer scientist and fascinated by energy. My first job was in the fusion program. That was a long time ago, and fusion's had a many decade schedule slip since. I built companies in the computer and semiconductor industries, but a little more than 15 years ago, I built a first solar startup that was focused on solar thermal. I was particularly looking for solutions, technologies that could drive large flows of private capital into energy infrastructure. Built a company that we sold to the French nuclear giant Areva. I was briefly a VC. I met the founders of another solar thermal startup that was specifically focused on industrial heat. And with that technology, concentrating solar, we built more than half the world's solar industrial heat. Lots of lessons living in the Middle East and Latin America, and lots of failure to bring projects to the point that they were investment grade, ready for infrastructure capital. During that time, we did build a lot that was on customer balance sheets. And we spent decades looking for thermal energy storage to tie to those technologies. Because the one number one thing that when you want to repower industry, you've got to deliver energy that's cheaper than business as usual, but it has to be continuous as well. So thermal energy storage was a key need. And we started Rondo with that experience, but in a new world, because we now live in a world where we can have continuous energy if we can harness the intermittent energy that's now available from wind and solar, which has fallen to a price point in lots of the world where solar PV power is cheaper intermittently than burning fuel, not just cheaper than conventional electricity, but burning fuel.
So just to be clear, for the purposes of Rondo Energy and what you're doing today, is it a solar tech or is it what's the source of power?
Mm,
How you get? Help us understand that.
yeah, the Rondo is storing intermittent electricity. We charge by heating material and delivering continuous energy. Right? We now live in this world where we can have intermittent electricity cheaply. In the United States, Oklahoma last year had 2,000 hours of negative grid electricity prices, driven by the production tax credit. And the Inflation Reduction Act is bringing a ton more of that. Around the world, as renewables deploy, grids run out of flexibility of thermal power stations, and we see more and more negative prices emerging around the world. So we built a unique, very cheap type of energy storage to harness that intermittent, low cost and negative power and put it to use by storing it to deliver industrial heat to replace boilers and kilns and furnaces.
Oh, that's fascinating. Yeah, because what I know about, renewables, solar and wind in particular, right, is, and many people understand the intermittency of it. The solar works when the sun's shining, wind works when the wind's blowing, but the challenge is it's not base load.
Yeah.
Um, And so,
Exactly.
and I appreciate you bringing up Oklahoma because I'm from there, so I understand that neck of the woods. And so it's interesting to me that, for like a state like Oklahoma, where they've got a lot of wind and they've been able to utilize the wind for intermittent electricity with your technology at Rondo Energy, what you're telling me, if I understand correctly, is that could be one of the components that is connected to a wind farm, for instance, to then generate baseload power for electricity for residences or commercial uses, industrial, or who are the actual customers?
We're focused on industry, right?
Okay.
Industry around the world uses about a quarter of all the fuel in the world for industrial heat. And industry moves to where energy is low cost. Why did the factories in England in the 19th century all get located on the coast? That was where it was cheap to bring the coal. What happened in Oklahoma and Midland, Texas? What happened in the middle of the US when we had the shale revolution? Tons of industrial investment, tons of job creation, harnessing low cost natural gas. We are now in this era that renewable electricity, overwhelming grids, people have thought this is a problem. The marginal cost of bringing another wind farm online when most of its production is going to be during periods when prices are negative, that's a challenge. But that intermittency, that price volatility is suddenly this enormous opportunity to put that energy to work that we would otherwise discard or have to pay somebody else to take and put it to work, making everything from cement and lime to baby food. Every single industrial process that uses heat, those can be repowered now with intermittent electricity because we finally have storage that is cheap enough, safe enough, hot enough, efficient enough to play this role that what we thought was a problem on the grid is a solution to industrial energy and industry's need for energy. The thing happening on the grid is a solution for that because we can't talk about decarbonizing industry unless we have a solution that is lower cost than business as usual. Policy approaches that say thou shalt may wind up making industry move elsewhere, deindustrializing instead of decarbonizing. And the phenomenal thing that we are at this moment right now where we have primary energy at a price where if we harnessed it, we could drive deep decarbonization and industrial growth and international competitiveness and job growth.
So who is your ideal customer then? When you say industry, is it as energy intensive as say glass manufacturing or cement factory, or more commercial oriented like a data center or a big commercial building, or everything in between?
We're primarily focused on the large users and the large users of heat. If we go down, where do we actually use fuel for manufacturing in the US? Number one is fuel refining. Number two is chemical production. Then we get into food and beverage, paper. Then we get to things like cement and iron. So we're really focused on the industrial loads. The smaller building loads, other things do add up to a big number, but they're dispersed among thousands of small things. So from a dairy to a biorefinery, all the way up to a petrochemical complex are the places that we're deploying right now.
Okay, wow, that's exciting. So help me, just because I'm a little bit of a tech geek, I want to understand, like, help me understand the technology. Walk me through, let's say I'm a refinery. Where does your technology actually sit at the refinery? And so I guess that's also plugged into a wind farm or a solar farm that then generates the tech, or how does that actually work? And then help us understand the process of your tech.
So by design, if you're running a refinery or any of those facilities, this is a simple drop-in solution. You've got a set of cogeneration units and boilers that provide the vast majority of your primary energy use, the steam that's used to drive everything from pumps to distillation trains to all sorts of process units. Today, that steam comes from boilers and cogeneration boilers that tie to a steam network. We drop in connecting to that steam network somewhere alongside all that infrastructure, and you'll just turn down those boilers. You'll burn less fuel. We'll connect to a steam flange on one side and to a high voltage substation on the other side. Now, that power may come from new build local generation. It may come from tying to the grid. It may come from an existing wind farm on some special arrangement. But there are many different places the electricity comes from. And we're working with dozens of electricity developers and utilities for whom we're creating giant new opportunities to sell renewable power that was otherwise being curtailed, to build new generation facilities right now rather than waiting for the grid to make them possible. But from the energy user, this is an opportunity either to own capital equipment or just sign a heat as a service contract and buy steam over the fence without making a single change to the existing facility.
And can you tell us more about the technology? What exactly? So you've got, what's in the black box, if you will? Or can you talk about that? Is it,
Yeah.
yeah.
Not long ago, Tesla released an assessment that ultimately the world's going to have twice as much heat battery capacity installed as grid batteries of all kinds, because this is for sure the cheapest way of decarbonizing industry. And today, there is an enormous diversity of technologies that are trying to be brought to market to serve as heat batteries. Heat batteries have to do two things. They have to charge fast. The faster they can charge, the lower the cost energy they can capture. And they have to deliver energy continuously. If I want to replace a boiler that's turned off once a year, I need to build something that's turned off once a year, but all that time delivers continuous heat. We found, and today there are more types of materials: liquid tin, liquid silicon, liquid aluminum, liquid steel, carbon, concrete, liquid salts, many things being tried. 200 years ago, the steel industry figured out high temperature heat storage. Every blast furnace has a set of things called Cowper stoves that save coal by capturing heat at 1500 degrees C and delivering continuous heat at 1200. They're full of brick just made from clay. And that brick material there's 750,000 tons of in service right now. Our contribution, we figured out how to heat that brick the way your toaster heats bread. That is, with radiant heat instead of with a fluid and pumps. And we found a way to build a heat battery that's a combination of electrical heaters that are embedded in a special 3D checkerboard structure of brick that then delivers continuous superheated air, that we build a boiler in that's just like the existing boilers. Or for the higher temperature applications, we deliver superheated air directly into a kiln or a furnace. But most of our business today is drop-in boilers that are just like the existing ones. And it's a box that's a lot like a conventional boiler, except instead of a firebox inside, it's got hundreds or thousands of tons of brick that's glowing yellow hot inside at over 1,000 C, that's storing energy that came from from wind or solar power.
That is fascinating. I mean, it's just incredible. I mean, I'm pretty excited to learn about this just because I know for so long, renewables have not been really a good fit for
Yeah.
industrial heat because you need such, intense heat. And so you've taken something from what we knew in the past that was working, but maybe just applying it differently for these purposes with some newer, updated technology. So tell us about your installations. Where are you guys in your commercialization pathway? How far is the tech in, it sounds like it's beyond bench scale. Is it an operation scale, and where, help us understand kind of where it is in the kind of market formation?
Yeah, our vision to get to create a big market, we need a number of things. We need technology that works, that's field proven, that's deliverable at scale, that's got third party assessments of it, and now has deployment after deployment in different industries. That's the journey that we've been on, starting from the beginning, backed by Breakthrough Energy Ventures and Energy Impact Partners, who are backed by the electric power industry in the US, joined by Rio Tinto, the world's second largest mining company, Microsoft, Aramco Ventures, SABIC, the world's largest chemical company, and an infrastructure fund. We've been on this journey to deliver early units, prove the technology, and then deliver at scale around the world. For more than a year, we've now been operating a commercial unit that's tied into the steam system at a biofuel refinery here in California. Every gallon of biofuel the world produces right now, people are looking at putting it into an airplane wing. You know, the drive for sustainable aviation fuel is coming with a drive to make sure that those fuels are as low carbon as possible. Rondo at an ethanol refinery cuts the carbon intensity of the fuel in half. Takes a lot of energy to brew beer and then distill it into pure alcohol. Um, as it happens, just recently, the Department of Energy, among the 33 decarbonization projects that they announced, two were projects with Rondo. One of them was also distilling alcohol to make whiskey. Diageo will be making whiskey at two locations powered by Rondo heat batteries. We're excited to be working with them because they have been driving every type of decarbonization and recognize that this is a simpler, cheaper, deeper decarbonization pathway than some others. We're also in a large scale petrochemical project as well. Again, powering processes with zero carbon energy. And the Department of Energy grants were really, I found that breathtaking, the breadth of industries that they're addressing, the breadth of technologies that they're seeking to bring first of a kind, full scale commercial installations, because that's what we need. You know, there's a gap between early technology development that can be backed by venture and can deliver venture kinds of returns and projects that are investment grade, ready for conventional infrastructure capital, this kind of money in the middle so that early life technologies can be proven at the scale needed so that the giant capital flows can follow. There are, you know, again, there's a diversity in all kinds of industries. And though these first two projects with the DOE, alongside what's already happening in Europe, because EDP in Portugal recently announced larger deployment with us in their commercial solar business. But taken together, the work that we have already done in putting in place some of the world's largest energy storage production capacity now and laying down now more than a year of successful commercial operation. The DOE projects and the EDP work in Europe is setting the stage for very large deployment over the next couple of years.
What you talked about, sort of that money in the middle, it's interesting. I was at the Department of Energy, and when I was there, we spent a lot of time focusing on, what people call the Valley of Death. Um,
That's
and
another good term for it. Yes. Okay, let's go there. The Valley of Death. Yes.
and so this is where it's interesting because, I mean, not to get too far afield into, from your tech, but I think it's important to understand like how important what is the role that the Department of Energy plays in relation to your company's technology, and why is it necessary? Because, some might say, look, if the market's big enough, why do we need, DOE to step in when there should be plenty of investors and plenty of, market, appetite out there for your tech? Um, I've got my own answers, but I'll let you answer it because I'd be curious to know, just from a fresh perspective, how you think about that valley of death and that money in the middle that's necessary. Why is it necessary when you've got big backers like Breakthrough Energy Ventures and big companies like Rio Tinto. Why is the Department of Energy money important?
It's about what the Department of Energy is doing now. It's about leadership. It's about deep tech diligence, and it is about market catalysis and transformation. I was on a panel with the head of sustainability for one of the consumer brands not long ago. He said, "My factory teams always hate it when the decarbonization team shows up, right? They want them to tear the factory apart, install stuff that they're not familiar with, maybe raise production costs. And that goes against every one of their KPIs. And there's nobody in that factory that has a day job figuring out tomorrow's energy technology. And there is always the, oh, we need to figure this out sometime. We'll get to it eventually. Um, the work the DOE is doing, as again, across this breadth of industries, has focused attention. We have seen a number of projects now starting to move forward, whether or not they were in that DOE basket, precisely because the DOE bringing technical attention and bringing the potential for grants has focused or catalyzed internal working groups at many industrials saying, well, let's look at this now rather than 2 years from now. So that alone has been valuable. Another is the DOE has brought expertise from the national labs and across the agencies doing deep dive technology assessment. And on the projects they've awarded, there's an important market impact in, oh, look, we understand this has been vetted at another level than the venture capital level. And the field experience that those projects are going to deliver, again, is moving to the very high investment grade standards that are needed for low cost infrastructure capital. Infrastructure investors need to know, is this thing going to operate for the 20 or 30-year term across which I expect to get return on my investment?
Yeah.
And early life technologies fall into this valley of death where delivering energy services to an energy user, the cost of capital, the rate of return to the capital infrastructure investor, can be half or three-quarters of the cost of energy. And the readying technologies so they can participate in large-scale infrastructure capital. Again, the DOE grants that were just announced, I think, are catalyzing about 3 times more money, private money, co-investing in those projects. But we see the huge impact is there will be tens, hundreds, eventually thousands of times more money of private capital that's in technology that has been, let's use the term, de-risked. We think the technology has already been de-risked, but proven de-risked,
Yeah.
so that it can participate in, some of the greatest business opportunities of our time are investments in large-scale renewables. And we've seen other energy storage technologies, lithium ion most notably, now being taken up at scale, delivering returns for hundreds of billions of investments around the world, moving our technology and other new technologies into that class so that they can participate and open a whole new wave of business opportunity of projects that deliver attractive returns, are at scale, and can be built right now. We're building a large islanded project right now. One of our DOE projects, we expect also will be islanded, not needing the grid at all, so that we can build now rather than waiting 7 years for grid interconnection delays.
It's so important that you talk about this de-risking, because I think that's an area where, again, so often, as I've first heard and learned through experience, that many investors don't want to be the first or second, or even maybe they're willing to be the third, but they want to see multiple systems in operation in the field, in the environment that which they're going to operate for X number of years before that capital can really come in. I mean, the technology has to be de-risked. And to your point, some investors take technology risk, not many, But most investors take financial risk or business risk, and so that really is the space I think where the Department of Energy plays well, and some unique investors like Breakthrough Energy Ventures and a few others who are well capitalized and willing to really take on that high risk. So tell us about Rondo. What's in the cards for the future? Where are you guys headed next year? And is your plan to go public? But give us a sense of like how quickly can your technology scale around the world, and are there any barriers that exist that we need to know about?
Thank you. Great questions. And we are focused on speed and scale. By design, we have chosen foundations, completely conventional boilers, this brick that's at giant scale, and focused on creating partnerships. Our first production partner for brick is an international quality award winner producer doing business in, I think, 80 countries. We have announced with them the world's largest energy storage manufacturing capacity. And we are focused on scale, planting first of a kind projects across half a dozen countries and different market applications to prove the technology can be built, can be reliable, can be low cost, and can have certainty of delivery in a wide range of applications, and setting the stage for rapid deployment going forward. And the company has, I think, as you know, Breakthrough Energy Impact Partners, and now Microsoft, Saudi Aramco Ventures, SABIC, Rio Tinto as investors because they see our technology as important to their decarbonization aspirations. Long duration energy storage powering data centers, high temperature energy storage powering the production of everything from aluminum to copper to ethylene to a wide range of the primary feedstocks that serve the modern economy. The company is growing rapidly. Our main topic right now, and for the next probably 2 years, is standing up worldwide delivery. We have a rigorous process right now for canceling incoming projects. That is, we can only deal with about a fifth of the demand that we're seeing, and we're really working to grow the organization. To that end, we will be doing another financing this year that enables powering that growth. And as I said, we are seeking the partnerships, the financial partners, both on the infrastructure side all the way to the energy users, for whom we're kind of mutually transformative. We're really seeking the partners for whom and with whom we can create the greatest value, and looking through the lens of speed and scale.
So John, if people want to learn more about the company, give us your website.
Yeah, it is rondo.com.
Rondo.com. All right. John, I really wish we had more time. I want to learn more. I'd love to come see your technology. And I love this concept of, basically, taking bricks and turning them into long-term, energy storage heaters, and being able to do that industrial scale. So I just think it's fascinating. I've got all other kinds of questions around your supply chains, but maybe that we'll save that for the next conversation.
Right.
I really wish you and your company all the best. I'm excited about what you're doing. We at C3 Solutions would be happy to look forward to just promoting, new innovations like what you guys are doing, and new kind of milestones as you achieve them. So please keep us in the loop. Anything else you want us to know about you or the company?
Thank you, Drew. You are more than welcome. Come visit us. We'd love to explore that with you. No, thank you. I think we covered it. I don't believe there's anything in any venture capital portfolio today that can go to this scale at this speed. Systemic recently released an assessment of this class of technology, finding that we're talking about 40% reductions in fuel combustion for industry in a decade. We see a clear path to about 15% reduction in total world CO2 over 15 years, and there are no material supply chain constraints to that. It is an enormous financial opportunity, and we are focused on creating the markets where it's financially compelling for infrastructure investors and energy users. That's true in a bunch of the industrialized world today. And because what's happening with wind and solar, it will be essentially everywhere in the industrialized world in the next 7 years. So, and I'd love to explore how do we work with C3.
Yeah, one, we're gonna take you up on that offer to come see your facility. We'd love to see that, and let's just stay in touch. So
Great.
thank you very much for your time, and for our listeners and viewers, again, this has been C3 specifically focused on tech voices, where we love to hear about new technology, specifically in the clean energy space, what's going on, and to have conversations with entrepreneurs like John and Rondo Energy. So if you know of any other technologies or companies that you want us to be covering, please let us know at c3newsmag.com. You can subscribe to our newsletter. It's free. We won't ping you too much, but just want to stay in touch on cool tech. So again, John, thank you so much to you and Rondo, and we'll stay